Here we're going to look at topic 9, example 1, understand point-slope form of a linear equation. So A, how can you write the equation of a line using any point on a line? What we're going to do here is show how we derive the point-slope form, and that comes from the equation, the slope formula. So m equals y2 minus y1 over x2 minus x1. What you're able to do is I can then y2, x2, I'm just going to change those to y and x without the subscripts. Right. You'll see why. It just kind of cleans the problem up a little bit for us. But then I'm going to get rid of that denominator. So I'm going to multiply both sides by that x minus x1. And those would cancel out. I'm going to put the m on the left side. So I have m times x minus x1 equals y minus y1. I'm not going to distribute here. What I am going to do is I'm just going to switch sides. So I'm going to take the left and the right side and swap them. So y minus y1 is equal to m times x minus x1. And this right here is my point slope form. All right, and that's where that that's where that formula comes from, is taking the slope formula and just manipulating and moving pieces around, and that allows you to derive that point slope form. When you're working with point slope form, it's pretty obvious based on the name. It works best when you have a point and a slope. If you're given a point and a slope, what you're going to do is you take the slope and you plug it in as your m value, right? We know that. And then the point, whatever point they give you, your x, y values, those get plugged in. That x value gets plugged in as your x1, and the y value gets plugged in as your y1. So we call these x1, y1. What you do want to be very, very careful of is when you have negatives as your x's and y's, or x1, y1. Make sure when you're substituting you use parentheses, and you'll see that in the next video. But really, it's really direct. You plug in your x, your y, and your slope. You just have to be careful. Just take your time with it. Make sure the signs are correct. Right? Outside of that, there's really not a whole lot that can go wrong. In part B, the question is, why is it helpful to have point-slope form in addition to slope-intercept form? I already wrote out the explanation, but basically what point-slope form allows us to do is to write the equation of a line without the y-intercept. We worked with slope-intercept in the previous section, and slope-intercept only works if you have the y-intercept. So you need a very specific point. Whereas point-slope form, you can use any 2 points on the line to write the equation. It doesn't matter which points they are. They don't have to be specifically the y-intercept. It could be any 2 points, and then you can use those 2 points to come up with a slope, and then use that slope and one of the points to plug into point slope, which you will see in the next video and the next example.